Good morning, viewers. This is Kasturi Day. Today I'm back with the chapter motion chapter in one motion in one dimension chapter. This is the second chapter according to ICSE syllabus class 8 physics chapter. This is then actually before starting, I would request you to please do uh, subscribe my channel and stay tuned with me so that you can get the notification as soon as the video is uploaded. Okay, so for that you need to ring the notification bell also. And if you liked the video, press the like button, share with your friends and colleagues so that they can also be benefited from these videos. And also do meditate before starting your day, and also you can also do meditate in between your works, whatever you are doing, maybe your studies, maybe some household work, or maybe office work, you or your parents, anybody can do these meditations. I tell my daughter also to follow this, and she is being benefited from these meditations. You can become successful, I tell you. Please do practice this meditation process, and this will help you a lot. Okay? So let us meditate for 1 minute and then we'll start the discussion. Okay. So for meditation, please to concentrate on a point of light. You can light a bulb also in your room and meditate on that. Think that this ray is reaching you, giving you lots of energy. The whole body of yours, from head to eyes, mouth, your neck, your throat, your hands, your chest, your stomach, your legs. Everything is getting energized. Every part of the body is being energized. You are so enthusiastic. You are so powerful becoming. You are becoming so powerful. You are feeling very good, very happy, feeling interest in everything, solving everything very fast, doing your job, whatever job you're doing very fast, you're completing it successfully. Okay? So let's start here and continue with our discussion. Okay? So today's topic we'll start with is acceleration. So what is acceleration? It is the rate of change of velocity with respect to time. Okay, it's a rate of change of velocity with in unit time. That is, in, let's say 1 hour, how much the velocity is changing from initial to final velocity, how much it is changing. That will give you the acceleration. Okay, it is a vector quantity again. Because it has magnitude as well as direction. Okay, and its unit is meter per second square. Okay, velocity is meter per second and time is second again. So meter per second. That's why meter per second square. Okay, then acceleration, that is denoted by a small a. Velocity is denoted by small d, and the change in velocity is denoted by a delta triangle, that is called delta. So delta v, that means change in velocity. Then change in time. Time is denoted by t, and delta t means change in time, which is represented by the equation small a is equal to delta v by delta t. Okay. Now, types of acceleration. How many types of acceleration are there? One is uniform acceleration, non-uniform or variable acceleration. Next is instantaneous acceleration, average acceleration, negative acceleration. Okay. So first we come to uniform acceleration. What does that mean? When an object is traveling in a straight line, Okay, when an object is traveling in a straight line with an increase in velocity at equal intervals of time, then the object is said to be in uniform acceleration. For example, if a car is moving with a velocity of say 10 meters per second in 1 hour, in every 1 hour it is increasing its velocity by 10, that is 10 times. That is 10 meter per second in first hour, then second hour it is 20 meter per second, in third hour is 30 meter per second. So it is at equal intervals of time, it is increasing its velocity. Okay, so that is an example of uniform acceleration. Okay, so for example, a free falling object. Okay, when an object is freely falling from up to down, so that will have a uniform velocity. Sorry, uniform velocity as well as uniform acceleration. Now, non-uniform acceleration or variable acceleration, where the velocity is changing, but it is changing at not at equal intervals. It's equal not at equal intervals of time. That is, its time interval is not equal. Okay, for example, see if the car is moving in the road, uh, say it's moving due north, it's moving to in the north direction, and its velocity for first hour is 10 meter per second. For say for next 2 hours, it is 20 meter per second. Then for next 1 hour again, it is 15 meter per second. So velocity is increasing, but that is not uniform, but it is moving in one direction. So it will be variable velocity. Okay, there will be variable velocity at unequal intervals of time. That is known as non-uniform velocity, non-uniform acceleration. Like bus moving or leaving from the bus stop is an example of non-uniform acceleration. When it is leaving the bus stop, it is increasing its velocity, but when it is stopping, it will decrease its velocity. So like that, there is non-uniform velocity or variable velocity. Then we come to instantaneous velocity. What is that? When acceleration of an object at any instant of time, acceleration of an object at any instant of time, like at 10 p.m., what is the acceleration of the object at at 9 p.m., what was the acceleration of the object, like that. So at any instant of time, what is the acceleration of an object? Okay. Then average acceleration. See, it is defined as the total change in velocity in a given intervals of time that is divided by the total time taken. See, when the velocity is changing, say it may be in equal intervals or in unequal intervals, it is changing. It is in the, I mean to say that it may be non-uniform or uniform acceleration. But when it is the total journey is complete, what do? To take out the acceleration, we total up the velocities and divide by the total time taken. So that will give us the average acceleration, and that is denoted by small a, which is underlined above with an arrow. Okay. Negative acceleration, which indicates the direction with an arrow above a, denotes the what is that? The direction of the object which is moving. Then negative acceleration, if the velocity decreases with respect to time, that is known as negative acceleration or retardation or deceleration. Okay, so like say if the train is reaching the station, it slows down, so it is getting retarded. It is decelerating its motion. Okay, it is said the train is retarding. Retardation is acceleration with a negative sign, or the negative value of acceleration shows that the velocity of the body is decreasing. Okay. So the acceleration is denoted with that is small a, which is denoted above with an arrow above it to indicate the direction as it is a vector quantity. Okay. Now see, to calculate acceleration, we need to take the final velocity and the initial velocity, and the time should be known. And we subtract initial velocity from the final velocity and divide it by time to get the acceleration. Now to take the velocity, we need to know the displacement, which is denoted by x here, final displacement and initial displacement divided by the time. Okay, so final displacement is xf and initial is x0, and get the difference, and then it is divided by time, which gives the velocity of a object. And then by making the final velocity and initial velocity, we and divided by t, we get the acceleration. Or you can write it in this way also, that Vf is equal to v0 plus at. Okay, that is final velocity is equal to initial velocity plus acceleration into time. Okay. Now, this A is acceleration, Vf is final velocity, Vo is initial velocity, then T is time taken, Xf is final displacement, Xo is initial displacement. And if Vf is greater than V0, that is final velocity is, if it is greater than initial velocity, then acceleration becomes positive, that is acceleration. Okay, A is positive and it is acceleration. Okay, and if final velocity is less than the initial velocity, then A is negative, and that is retardation. That is not acceleration, but that is retardation. Okay. Then the acceleration does not determine the direction of the motion, but the velocity determines the direction. By knowing the value of acceleration, we cannot determine the direction of the motion. The direction of the motion is denoted by the velocity, because velocity is given by the displacement. So actually the displacement gives the direction, and that is taken by velocity, and that is also taken by acceleration. Okay. Now, the positive and negative sign on A indicates the velocity is increasing or decreasing. If it is positive, then velocity is increasing. If it is negative, velocity is decreasing. Okay. Now, the positive and negative sign of velocity indicates the direction of the motion. The positive and negative sign of acceleration here so shows the velocity is increasing or decreasing, and the positive and negative sign on velocity will indicate the direction of the motion. If the positive sign is there, that means it is moving away from the source. Forward it is moving, and when it is negative, velocity is negative, then it is coming back to the source. That is, it is moving backward. Now we come to acceleration due to gravity. Okay. What is acceleration due to gravity? When a body falls towards the earth, when the body falls towards the earth, it experiences a change in its acceleration. Okay, its acceleration increases. Why? Due to Earth's gravitational force. Earth will pull the object towards it, and this pull, this acceleration, which is experienced by the object due to the gravitational force of the Earth, is known as acceleration due to gravity. The Earth's gravitational force is known as gravity, and due to the gravity, the acceleration experienced by any object is known as acceleration due to gravity. Okay, and its unit, SI unit, is again meter per second square, like other acceleration also. As the acceleration due to gravity has both magnitude and direction, so it's a vector quantity. Its standard value on the surface of the Earth at sea level is 9.8 meter per second square, or 10 approximately. Okay, so on the surface of the Earth, its it's I mean, on the surface of the earth at the sea level, the acceleration due to gravity of any object is 9.8 meter per second square. Mathematically, the acceleration due to gravity is directly proportional to the mass of the object and inversely proportional to the distance of the center of the mass. Okay, so it is given by the formula small g, that is acceleration due to gravity, is equal to g, capital G into m divided by r square. Capital G is gravitational constant, m is the mass of the body, and g is directly proportional to mass and inversely proportional to distance, to the square of the distance from the center. Okay, so r square, so distance from the center. If we consider Earth to be a sphere, then from the center, the distance towards the surface of the Earth is considered to be the radius of the Earth. So the distance from the center of the Earth to the surface of the Earth is called the radius of the Earth, and that is denoted by small r. And the square of the distance, the small g, that is acceleration due to gravity, is directly proportional to mass and inversely proportional to the square of the distance from the center or the radius of the Earth. Okay. Now, what are the factors which determine, which affect the acceleration due to gravity? First factor is altitude above the Earth's surface. If the object is, how much the object is above the Earth's surface. What is the height of the object from the Earth's surface above it? How much, or how much it is below the Earth's surface? How much below the object is inside the Earth's surface? Or the shape of the Earth. If the shape of the Earth is a sphere or a slightly elongated, like an egg-shaped or oval-shaped like that. How is the shape of the Earth or any other shape? And the rotational motion of the Earth, that is spinning motion of the Earth, okay, around its axis. So these are the factors which affect the acceleration due to gravity. Now, as the value of g does not depend on the mass of the body, okay, value of g does not depend on the mass of the body. So if two bodies of different masses, generally what happens, we know that it is directly proportional to the mass of the body. That is, if mass increases, acceleration decreases. But in case of vacuum, what happens, this mass is not dependent, is not does not affect the acceleration. So what happens in the vacuum, when two bodies of different masses are simultaneously dropped from a height, then both will reach the ground simultaneously. Okay, but if it is in air, in where there is no vacuum, then what happens? The mass with higher, I mean the body which is having more mass will reach the surface of the Earth more fast than the smaller one. Okay, the lighter one. Okay. This is due to the fact that there is no effect of friction and buoyancy due to the air. There is no air, so there will be no friction and buoyancy. But in case of ordinary conditions, what happens? There is air, there is friction, and that's why it will obstruct the lighter ball to come down. And the heavier ball, the mass, the ball which has heavy mass, the body which is having heavy mass, that will go against the friction of the air and it will come down fast. Okay. Now, on the Earth's surface, G is maximum at the poles and minimum at the equator. Okay. When it is near the equator, the acceleration due to gravity is minimum, and when it is near the poles, that will be maximum. Okay. Because why? Because the Earth's shape is bulging towards the equator and flattened towards the poles. So from the center, the pole is nearer, and from the center, the equator is far. That's why the distance, the radius, that is the distance from the center of the earth to the surface of the earth at the equator is more uh, s- uh, than the distance from the center of the earth to the poles. That is why its G is maximum at the poles and minimum at the equator. The value of G decreases with altitude and depth from the Earth's surface. What happens? When we go up, as the altitude increases, okay, as the altitude increases, the value of G decreases. As the distance increases, the distance from the Earth's surface increases, that will decrease the value of G. Or if it decreases below the Earth's surface also, that will also increase the uh, value of G. If the depth below the Earth's surface increases, then that the value of G will decrease. Okay, otherwise, I mean, both sides it is applicable. Now, next topic is graphical representation of linear motion. So, to represent this linear motion, three types of graph representation are there. One is displacement time graph, velocity time graph, and acceleration time graph. Okay. So this I will start in my next video. Please go to this till what I have discussed. Go through it. If you have any doubts, please do let me know. Do write in the comment box. You can also you can write in my email ID. Okay, send me a mail at kasturi74@gmail.com. Okay, I will reply you as soon as possible. Okay, so please do that. And if you want any test to be done, you can also comment me. I will organize for that. I will arrange for that test. I will prepare the question paper for you all and post it, and you can answer them and then send me in my mailbox. Okay. So till then, have a good day and thank you for watching, and do meditate. Don't forget to meditate, do the meditations, okay, before you start your day. So thank you for watching. Have a good day.